Hello friends, welcome to this video on central limit theorem. We have been seeing about bounds and inequalities in the last and few videos. Now we saw about Chebyshev's inequality, which was one of the prime approximation theory. The second important concept which we can learn about approximation theory is the application of central limit theorem. When we have the average of the random variables or the sum of the random variables and the random variables are going to grow large in numbers, then central limit theorem is going to be a tool for the evaluation of the probabilities. We will see what are the formats of central limit theorem and how we can apply them to problems. The first format of your central limit theorem is referred by the name Lippanov form. So what is Lippanov form? It says that if x1, x2, x3 up to xn are going to be a sequence of independent random variable, notice they are independent. So one does not affect the other. And each of this random variable is going to have a mean given by mu I, and each of the random variables has an variance given by sigma I square. Then if I am going to consider Sn called as the partial sum. So when I sum the n number of variables, first n number of variable x1 plus x2 plus x3 up to xn, then under certain general condition, this partial sum Sn follows normal distribution. So when the number of variables are going to be bigger in number, then Sn follows normal distribution. So when it comes to normal distribution, I have normal distribution with two parameters, mean and then your standard deviation, which is represented as sigma. You have mean and standard deviation to be the parameters of your normal distribution. So what is this mean of Sn, in which case it follows normal distribution? The mean mu of your Sn will be the addition of all the means of this n random variables. So if x1 has mean mu1, x2 has mean mu2 and up to xn has mean mun, then the addition of all this random variable will have mean as the addition of all their means. And in a similar way, what about the variance of this Sn? It will be the addition of all the standard deviations or the variance as of the individual components x1, x2 up to xn. So when does this happen? We will have to keep in mind this happens when n tends to infinity. N tending to infinity meaning the number of independent random variables becomes very large in number. This is one format of central limit theorem as defined by Lippanov. The second one is called as Lindbergh-Levy form. Here we have x1, x2 up to x3, xn to be a sequence of independent and identically distributed random variable. So here we have identically distributed. Hence what happens is E of xi is going to be mu for all the number of variables. So each one of them will have the same mean mu. That becomes the difference from the Lippanov form. In the Lippanov form, each one of them had a different mu, but over here each one of them have the same mu. So what is going to be the mean of your Sn? The mean of your Sn will be n times of mu. And what is the variance of your Sn? It becomes n times sigma square. And when does this happen? This happens as n tends to infinity. So here every variable has the same mean mu and every variable has the same variance sigma square. So when you add n times of the data, so you have n mu and n times of sigma square. Now I know that the average of all the random variables, average or you can say mean of the random variables is denoted by x bar. So how to compute the mean? Mean is nothing but addition of the data divided by the total number of data. And what do we know about the addition which is there in the numerator? We know that this is nothing but our Sn. So we say average or mean x bar is Sn divided by n. Now how about the mean of this average x bar? the mean of your x bar will be equal to expected value of Sn by n. This n is a constant, so take it outside. What is expected value of Sn? Expected value of Sn is nothing but the mean of Sn. And what do you know about mean of Sn? Mean of Sn is n times mu. So n and n cancels off, giving you mu. So expected value of x bar is going to be mu. The next thing what I want is the variance. What do we know about variance of Ax? Variance of Ax is a square times variance of x. So what will be variance of 1 by n times of x1? It will be 1 by n square times variance of x1. Now when I have variance of x bar, so it is variance of x1 plus x2 plus x3 up to xn divided by n. So the constant 1 by n comes outside as 1 by n square, and you have variance of your Sn. What is the variance of Sn? It is n sigma square. So you have n sigma square divided by n square. One of the n cancels off, leaving you with sigma square by n. Hence, you have variance of your n x bar to be equal to sigma square by n, and the mean of x bar to be equal to mu. So, we need to keep in mind, when you have your Sn, the mean of your Sn is your n mu, and the variance of your Sn is n sigma square. When you have your x bar, the mean of the x bar is mu, and the variance of x bar is sigma square by n. So this is nothing but our variance. So when I want standard deviation out of it, what will be the standard deviation of this data? It will be sigma into square root of n. So Sn has mean to be equal to n mu, and standard deviation as sigma into square root of n. Your x bar as mean to be equal to mu, and standard deviation to be equal to sigma by square root of n. So this is how we try to say this Sn and x bar follows normal distribution. So when they follow normal distribution, what happens? X bar follows normal distribution with mean mu and sigma by square root of n. Mean mu and sigma by square root of n. When it comes to Sn follows normal distribution with mean n mu and sigma into square root of n. N mu and sigma into square root of n. So these are the two formulas we need to keep in mind for examination point of view to solve any problems in central limit theorem. So recollect one more time. X bar follows normal distribution with mu comma sigma by square root of n, and Sn follows normal distribution with n mu and sigma into square root of n. Thank you.